For question 19a, we've got to determine for which values of a this summation is convergent. And what we're going to use is the integral convergence test. So we're going to have a look at the integral between 2 to infinity. I'm going to rewrite this in a slightly different way. 1 over k times by the ln of k to the power of a dk. Now, what should be apparent here is that we've got the derivative of ln k actually sitting there in the numerator. So this integral should be solvable by using some type of substitution. And in fact, what we're going to say is quite simply let x equal the ln of k. And if we do that, then we can say that dx by dk is equal to 1 over k, and that will lead me to dx is equal to 1 over k dk. I'm going to have to change the limits as well, but I'll do that in a second or two. It would look a little bit strange if I started to talk about the ln of infinity, so I'll avoid that for the moment. In fact, what I'm going to say now is what we're really interested in is the limit as b tends towards infinity of the integral between 2 to b of 1 over k over the ln k raised to the power of a dk. And now it makes sense to say, well, okay, when k is equal to b, then x is equal to the ln of b, and when k is equal to 2, then x is equal to the ln of 2. And I can now say we're dealing with the limit as b approaches infinity of the integral. Now I'm going to change the limits, so that will become ln 2 on the bottom, that will become ln b on the top. I can replace the 1 over k dk that we see here with the dx, and the ln of k I can replace with x. So hopefully you can see I end up with 1 over x to the a dx. At this moment in time, I'm going to note it doesn't really matter that this says ln b up here, because as b goes towards infinity, well, the ln of b is also going to go towards infinity, so it isn't going to affect our use of the integral test. Okay, what we've got to be careful of here is that if a is equal to 1, we've got 1 over x, and we've got the logarithmic function. I think we'll come to that one later. So first of all, let's just have a look at the cases where a is not equal to 1. Okay, if a isn't equal to 1, then we should be able to integrate this directly. We've got the lim of b approaching infinity. Okay, so that would now be thought of as x to the minus a, so we add 1 to the power, so we get x to the minus a plus 1, and divide by the new power, which is minus a plus 1, and that's going to be evaluated between the ln of b and the ln of 2. Okay, so that now gives us the lim as b approaches infinity of ln b to the power of minus a plus 1 over minus a plus 1 minus the ln of 2 to the minus a plus 1 over minus a plus 1. And the question becomes, when is this going to be convergent and when is it going to be divergent? And in fact, all we really need to think about is this here. If that is positive, then ln b remains in the numerator, and if ln b is in the numerator, then I think fairly obviously as b tends towards infinity, then the ln of b is also going to tend towards infinity. It'll be divergent. If minus a plus 1 happens to be negative, then of course another way of looking at that is by moving the ln of b into the denominator, and in that case, as b tends towards infinity, then ln of b in the denominator tends towards infinity, and that term will tend towards 0. And if that tends towards 0, then all we're going to be left with is this second part, which at the moment is written as minus the ln of 2 to the minus a plus 1 over minus a plus 1, and that would be the limit that the integral would then go towards. So with that in mind, what we can say is if minus a plus 1 is greater than 0, then the integral is divergent. Now that's the same as saying if 1 is greater than a, which is obviously nice to look at if you say if a is less than 1. So we now know that if a is less than 1, we'll have divergence. Let's have a look at what happens for convergence. Well, we can now say if minus a plus 1 is less than 0, that means that it's a negative power, and as we said before, it puts the ln b to the power of whatever into the denominator, then the integral is convergent. And that gives me 1 like that, which obviously looks better if I say if a is greater than 1. So if a is greater than 1, we're going to have convergence. We now need to test the case where a equals 1, but I think it should be fairly obvious what happens in this case. It's a whole different integral that we have to deal with, because we're now dealing with between, was it the ln of b, the ln of 2, and the limit as b approaches infinity, and we now have here just 1 over x dx, which of course leads us to the limit as b approaches infinity of the ln of x evaluated between the ln of b and the ln of 2, which would give us the limit as b approaches infinity of the ln of ln b minus the ln of ln 2. And I think it should be pretty obvious that that's going to be divergent. Ln of b, as b goes towards infinity, tends towards infinity, so you've got the ln of that. Yeah, it's going to be divergent. That's the end of the first part of this problem.